In this question, you are given 3 points A, B, and C. And part 1, you are supposed to find the vector equation of the line L through AB, and then show that C does not lie on the line L. And after that, you are supposed to find the foot of perpendicular from C to the line L, and then determine the image of C under refraction with respect to the line L. The other two parts of the question, you look at it later. So first, you're supposed to find equation of the line L through A and B. So you'll find the direction vector. So A is 1, minus 3, 2. B is the point 0, minus 4, 5. Right? So to find AB, you'll be vector OB minus vector OA, right? And then we give you minus I minus J plus 3K. So with that, the equation of the line AB, right? The line L which passes through AB, you can use the point A, then plus lambda vector AB. You can also write it as R equal to, using point B, then it will be minus 4J plus 5K plus nu, then minus I minus J plus 3K. You can also use the point B instead of point A. So that's part 1. In part 2, you are supposed to show that C doesn't lie on the line L. You can do it by assuming, suppose C lies on the line L. If C lies on the line L, right, then you will find that vector OC must be equal to I minus 3J plus 2K plus lambda minus I minus J plus 3K for some lambda. Remember, the equation of the line we have found is this one. So if C lies on the line L, then vector OC can be written in this form: I minus 3J plus 2K plus lambda minus I minus J plus 3K for some lambda. So using that, right, you just equate the point C, the position vector of point C, which is 5I minus 3K. After that, you can compare the I component. 1 minus lambda must be 5. Then J component, 3 plus lambda with a minus sign must give you 0, because OC has no J component, so 0. And then you look at the K component, which is 2 plus 3 lambda must be minus 3. And then you solve for lambda. From the first equation, it tells you lambda is minus 4. From the second equation, it tells you lambda is minus 3. From the third equation, it tells you lambda is minus 5 over 3. So with that, you'll find that the answer is not consistent. You get a contradiction. So C doesn't lie on the line L. In part 3, you're supposed to find the foot of perpendicular from C to the line L, and then determine the image of C under refraction with respect to the line L. To do such a question, you can draw a diagram to help you. You can let P be the foot of perpendicular from C to the line L. And then after that, you're supposed to determine the image of C under a refraction about L. So C, if you reflect about the line L, it will give you C prime. So you take note that CP and PC prime, it must be equal. The image of C is C prime if you reflect about the line L. And since P is the foot of perpendicular, you should expect CP and PC prime to be equal. So you can draw this diagram, and then because P is on the line L, so OP, right, must satisfy equation of the line. So which means OP, right, the position vector OP must be also of this form: I minus 3j plus 2k plus lambda minus I minus j plus 3k for some lambda. With that, right, you can find CP. CP is vector OP, which I just mentioned is on the line. P is on the line, so vector OP must be I minus 3j plus 2k plus lambda minus I minus j plus 3k for some lambda, then minus OC. So that will give you this vector in terms of lambda. Then because CP is at right angle to AB, remember P is the fluid perpendicular from C to the line AB. So vector CP is at right angle to vector AB. Yeah? So that's why CP dot AB must be 0. So with that, you can work out the dot product. You give you 11 lambda plus 22 equal to 0. So if you solve for lambda, lambda will be minus 2. So you just set lambda as minus 2 to find your answer. So you set lambda as minus 2 into OP. So OP will be P will be the point 1 minus 2, 1 minus 2, then minus 3 minus 2, then 2 plus 3 minus 2. So with that you get this as an answer. The point P is 3 minus 1 minus 4, the fluid perpendicular from C to the line L. After that, we will be finding the image of C under reflection about the line L. To do that, right, you can make use of midpoint theorem. P is a midpoint of P will be the midpoint of CC point. If you write C and C prime, then P is the midpoint. So we can use the midpoint theorem. The midpoint theorem says vector OP must be half of vector AC plus vector AC prime, or use O. It doesn't matter which point you use, but if you use O, it's easier because you know OC and OC prime. So it's half OC plus OC prime. So with that you can times 2 to say 2 vector OP must be OC plus OC prime. So that means you are using midpoint theorem. So you can say by midpoint theorem, vector OP is half of vector OC plus OC prime, means times 2. So that's how you get this part. So with that, right, your aim is to find OC prime. Your aim is to find the image of C under reflection about the line L. So from here, right, you can say OC prime is, you just transfer the OC to the left hand side. So you can say vector OC prime is 2 vector OP minus vector OC. So that's how you get this part. And then you sub in your OP, which you have just found. OC is the point given to you in the question. So with that you get OC prime is I minus 2j plus minus 5k. So then C prime will be the point 1 minus 2 minus 5. In part 5, you're supposed to find a vector equation of the image of the line through A and C under reflection about the line L. The point A is on the line L, so which means if you reflect AC about the line L, then you should get the line AC prime. So it means the direction vector of the image line, you can take AC prime as your direction vector. So you take AC prime as the direction vector. So you'll find AC prime, which is OC prime minus OA. will give you j minus 7k. Then the point A is on the image line, is on the line AC prime. So the equation of the refraction line, right, will be just I minus 3j plus 2k, which is the point A, position vector of point A, and plus lambda, the direction vector AC prime, j minus 7k. In the last part, you are supposed to find the distance from C to L. To find the distance from C to L, you just need to find this length, CP. So the shortest distance from C to L, the distance from C to L will be just the length of vector CP. And if you work it out, the answer is just square root 6. So you just find value of vector CP, and the final answer is square root 6. CP is what we have done in part 3. Yeah? In terms of lambda is this vector, and lambda is minus 2. Or actually you can use your point P here and your point C given the question, which is 5, 0, minus 3 to find your CP. So with that, CP can be found, and finding the magnitude, it gives you square root 6.